So K-means is unsupervised learning. What is unsupervised means the level or predict target is not defined.
Okay, sir.
Okay.
So that means you don't have a target and you are having a sample that features. That data will be there, but there is no like this one. The data, if you see where I should show you. So there was three things, right? One is features. Features means what? The features which you wanted to train.
Yes, sir.
And the target is the target column.
Yes, sir.
So if I have to train the iris dataset using Kmeansclustering,
Yes, sir.
so let's say this one is there, right? So these are 4 features, right?
Yes, sir.
4 features. So let's say, and it is not given based on that the iris flower is a what type. So iris, if you see, has a 3 type. What is the 3 type is there from the dataset itself? You can see here. See. So we'll go to the example later on also, but I think more practical is required for you. See, these are 3 target type: Setosa, versicolor, and virginica.
Yes, sir.
So 3 types are target. So these 3 types are interpreted in the example as 0, 1, and 2. Here if you see, target you see 0.
Yes, sir.
Or down if you see 2. Between that is not shown. So 0, 1, and 2. So based on this type of features, sepal length, the iris dataset, do you know how it is look like?
Yes.
No?
Yes, sir. No, sir.
Okay, so I think he's joined or what? Give me a minute, I'm just explaining that there is.
Sure.
So these are 3 see features are there, right? So see, there are 3 types of flowers are there.
Yes, sir.
So like a rose are having a red rose, black rose, white rose, and yellow rose. So it has the features like this: the sepal
Yes, sir.
width, sepal length, and petal width and petal length. So only the leaf size is big and small. So based on
Yes,
that 4 features. So that's why, but the target is there. But what I'm saying is, let's say the target is not given for any problem. It may be anything like any document. Let's say a lot of document is there, and you have to find out it's a sports news or it's an entertainment news. So the thing is, we don't have. Let's say target is defined. It's not given a sports news or entertainment or political news. So then, how
Yes,
we
sir.
are going to train it? It's not a supervised. So that time, this algorithm will come into pictures.
Can you repeat the statement, sir?
When you don't have the target,
Yes, sir.
that time, can you off the video? Can you keep your video off?
My video off, sir.
Yeah.
1 minute, sir. Stop.
Once again, otherwise.
Yes, sir. Okay, sir.
Yes. So,
Sir. Hello.
okay. So, see, the target is here, right? 0, 1, 2. So when it is target is there, then we can use like a logistic regression for binary problem or any other classification algorithm we can use. But when we don't have this target and it is mentioned that the features are given and you have to find out 3 different types of flowers based on
Okay, sir.
sepal and sepal width and petal width. Then
Okay, sir.
then you have to do unsupervised learning algorithm.
That means the features are fixed, but the target is not.
Target is not at all there. You don't have a target to train.
Okay,
See, here it will happen like this. More practical sense if I give you at this moment only before going to the theory. See, when you do fit on logistic regression or linear regression, why you do fit x comma y?
Yes, sir.
Here you have to supply only the features, not target.
Yes, sir.
It is expected that there is no target. If it is the target is there, then we will not go for unsupervised learning.
Okay, sir.
Understood now?
Okay, so only whenever there is no target, we'll go for K-means clustering. Whenever we have a target, then we go for linear or logistic regression like that.
Linear and logistic is some, and there are many have to come. So
Okay, sir.
many are there, and linear, you know, when it is used for continuous data,
Yes, sir.
and for classification problem. So you have to do supervised learning, which falls into the classification algorithm. Classification, that is, one is binary classification. You got the logistic regression.
Yes, sir.
So now this is unsupervised.
Yes, sir. Hello.
Okay, 1 minute.
Sir.
Yeah, I'm just Nimshi, I'm just calling the guy, just telling him that tomorrow he can join because I already started. Yeah, hello. No, it's not required. Just to tell you that. So it's getting late, so I started the other candidate who missed few class in between. So he already long back joined, but he was missing with clustering and night base. So I'll take him to clustering. So tomorrow again, the same time we'll meet.
Tomorrow you'll take, sir. Okay.
No, Nimshi, not for you. I'm talking with other guy.
Okay, sir.
Hello.
Okay, sir. No problem. Okay, sir.
Recording image. If you're not able to log in, or how? Can you do a restart of this? So we close the meeting, everything. Control Alt delete and just kill the tags. What is the Control Alt is clean the tags, the process, and then it should work. And MC.
Yes, sir.
Yeah. No. I was talking to the guy.
No.
So you just that is a unsupervised learning, and how it works is like, let's say this is a original data, and only
Okay,
we can do by clustering, or clustering means grouping. We can just make a group of data.
okay, sir.
Yeah, but not we cannot value it like supervised learning. We cannot specify it is a something of type zero. I mean, we cannot specify. Let's say house pricing prediction house. So then what you get a target value in the price, right? 20 lakhs,
Yes.
25 lakhs. So, or is a logistic regression you did. So zero or one, survival or death. So zero means
Yes.
survive. But here you will get some numbers, but that is does not specify what is the value of it.
Okay, sir.
So K-means can be used for news clustering, news article clustering, also NLME detection, and so on. So we'll discuss, or NLME detection also I will discuss. So something I discussed with him. So if you can try to get out that, or else I will take class. So here if you see in this example, so what is trying to get is actually height and weight is given of t-shirt. A factory
Okay.
produces many t-shirt. Now the factory want to produce only, let's say, three type of t-shirt, so that all the 1,000 people, that is all the 1,000 t-shirt that is manufactured, so can be wear by all the group of people.
Okay, sir.
So we want, that means three types, three clustering we want.
Okay, sir.
So then if you see, this is a three clusterings we did out of the height and weight.
Okay, sir.
And here we did five clustering. Okay, 1, 2, 3, 5, 5, correct. So based on the size, whatever required.
Okay, sir.
So that means clustering requires you have to specify how many group you have to form. Three if you put, then three form, and five if you will put, then five will form. But how? Based on the features, right? Based on the features. What is features you already see it, like in the iris data set we have features, four features. So
Height, weight.
yeah, and here it will be based on the height and weight.
Yes, sir.
Now let's say how it is the algorithm is going to work. Let's say we plot as the data in this like this in x and y plane. So this algorithm work by taking 2 points, that is known as random centroid, C1 and C2. This will be take any random position in the space, two-dimensional space.
Okay, sir.
So it's like a C1 and C2. After that, we got the color in the blue because we calculate the distance of each point from C1 and C2 both.
So C1 and C2 can be placed anywhere, sir?
It is going to be placed anywhere by the algorithms to random position initially for the only first time. And after that, we calculate every point from both the centroids.
Okay, distance.
Yeah, so we take the distance of this point, also like this. So whichever is nearer, so blue centroid is nearer, so its color is blue. Here it is red is nearer, right?
Sir, but some points are there which are far for both the C1 and C2, no, sir?
It's not about far or near, whichever is near, closest to which centroid.
Okay.
Let's say this is far. It's not about far. This is the equivalent distance. The distance between these 2 points and distance between these 2 points.
Okay.
Whichever is less will be known as that is of that type only.
Okay, sir.
Then you get some point like this in the blue and the other is red. Right? After that, we'll take the mean of this all blue point.
Sir, what are these points are the nearer points to C1 and C2, sir? This point which you drawn for yellow line.
Yes, these are blue point, right? This is to blue centroids. These are nearer to blue centroids.
Okay, okay. Like that, we need to also draw for the red centroid also, sir.
Yeah, so just concentrate on that. So C1 and C2 will be random centroids. We take the distance of each point from both the centroid, and accordingly, which one is closer to the centroids will be colored in that level.
That means that should be closer to both C1 and C2. So the points you selected are the points
Which
which are
one?
closer to both centroid C1 and C2.
So no, this is the one point. Tell me, is this closer to C1 or C2?
It is closer to C1, sir.
So that's why it is marked as red. This is closer to C2.
C2.
That's why it is marked as blue.
Okay.
Understood?
Okay. The points which are closer to C1 are marked with red, and the points which are closer to C2 are marked with blue.
Yes.
Okay.
And after that, we get all the blue points and we take the mean of this point.
Okay, of all the blue points.
Yeah, then the centroid will move something in the mean position.
Okay.
And again, this red position we also take, and we take a mean, and there the C2 will be moved. So how it will
Okay,
move
sir.
like this, based on the central position.
Okay.
It will move on the central position. Once it is moved, immediately all are not blue. Again, we take the distance of every point from blue and red samples. We got the central
Okay.
position here and here moved, and after that, we again take all the distance. Then what happened? This point, blue point, earlier was blue. Now in this chart, we'll convert it into red because the distance earlier it was nearer to blue point. Now in the new centroids, the new centroid it is far from this one, so it is marked as red now.
Okay,
And
sir.
some points these are earlier red. Now because of closer to this point will be marked as blue. Understood?
Okay. Okay. Yes, sir.
So we took random centroids here and there, and we take the distance of all points, and we mark as blue. But then we take the mean. After taking the mean, the centroid has been moved. After centroid has been moved, then again we take the distance of every point. In that case,
Okay,
it
sir.
means some blue points will be red and some red will be blue.
Okay,
Again,
sir.
next iteration it will move like this to middle of it.
Okay, sir.
So how it will move again? That means it will repeatedly do two things.
Yes, sir. First, it will take centroid C1 and C2 and measure the distance between centroid C1 and C2, and which are closer to the centroid C1, it will take that color, and for the centroid C2. Again, it will perform another iteration, and again the centroid will be moved to the next new position, and again perform the second one.
Yeah, centroid will be moved to not nearer position. Centroid will be moved to the mean.
So mean position, yeah. Yes,
Yeah,
sir.
mean position, and mean of that what? All the points that is
Point.
first. Yeah, first time we take the mean of these samples. That was somewhere here. Then we take this point. The position is here. Then again we calculate all the distance, and these will become blue points. So again, these blue points again we have to take a centroid, and it will move here. So
Okay,
the
sir.
red centroid again will move to here, right?
Sir, all this done in programming. In a programming, when we write all these computations, will be done by the program itself, no, sir? Like the calculation of mean and everything.
Yeah, automatically will taken care by sklearn, scikit-learn.
Okay, sir. Yes, sir.
Yes.
Okay, sir. Understood, sir.
So, one second. Okay. So, yeah. So that means what? The C1 and C2 will keep moving unless every time it will follow these two things only. C1 will take the distance of all point, and then the items closer to that C1 center will be marked as blue one, and another will be red. Then taken the mean of that, the center will move to that position. Again, we'll do the one, the distance of each point from the centroid. Closer to that will be marked as again blue, otherwise left. So over time, what will happen? The centroid will move here and here, and that time uh, the closer items to the centroid blue will be blue only, and red will be red only. At one point of time, the changes will stop. When it comes to this position, these are all right closer to the circle only. So it will stop, right? So then what will happen at that time when the centroids C1 and C2 will stop moving, that time the algorithm will be stable and the clustering will be formed.
Sir, like how can we know that the number of iterations should be only 2 or 3? Now we can by looking the graph we're able to tell, but in programming how
Very
many
good. The
iterations?
graph will the maximum iteration it takes, it will keep on doing unless C1 and C2 will stop moving. It will keep on
Okay.
doing, but you can keep in limit by putting the maximum value iteration of k.
K.
Not k, maximum iteration. Maximum
Okay, max.
iteration.
Okay.
Yeah, so there one is parameter is there. That's we are going to use beyond that point because it can happen that the sample is very big and the center moves very slowly. And after one interval, we are not interested for millimeter changes or
Yes, sir.
nanometer changes. So that's why we can put a limit. And the number
Okay,
of
sir.
k, how much k will be required, that depends on how many clusters you wanted to form.
Okay, sir.
Right?
Okay, sir.
So when that C1 and C2 will be stop moving, and that is also known as this equation.
Is called as
When the minimum of j, that is j is equal to distance of C1 red and C2 blue. That will distance between this also will be minimum that time. So
okay, the distance between the two centroids. Okay.
yes.
Okay, sir.
So
Sir, by using this, how can we get the target variable, sir? Without like we don't. That means in unsupervised learning, we don't know the target variables. But
now
by
look at
K-means
yeah to
clustering,
understand and look at the problem.
yes, sir.
So this is the iris dataset that is present in SQL datasets.
Okay, sir.
Input load iris. So load iris will return the dataset in dictionary format because it is in scikit-learn package.
Okay, sir.
So we have loaded it. So where we can see the what is that data is there. There's key value. All are key. Data is a key, and the values are there. Target is a key, and target is there, but we because of that sample dataset, but we don't need this target because we wanted to do a unsupervised learning. So target names are three. How many? Three, right? So that's why
Yes, sir.
we know that three clusters are required.
Okay, sir.
And this is the description of the sample. Now that iris the keys will return you this one, whatever key is there. So out of that, we know that data is what? The dictionary is what value? Key. This is the name of the dictionary. And this is the key. So putting that, you will get the value in X. So this is the data. This is the data from your dictionary. So that data we put in data frame. pd.data frame. Then so, and also we put df dot columns is equal to iris dot features name. Iris dot features name is there, right?
Yes, sir.
Features name is what? Sepal and sepal width and petal width.
So when you write id.keys, it will automatically, that means it will give this one, sir, data target name and all this one, or
Yes. That is because this is in dictionary format.
okay, dictionary format. Okay.
You can see, right? This one is dictionary format. You should have to remember. All SQL data sets are in dictionary format. See the curly bracket. And key colon value. Everywhere key colon value. So df dot columns we put it so that, and after that if you put df, yeah, down I already put it, so I think this is not required. Give me a minute. So this is the df dot columns we put the features name. That's why these features are all coming up.
Okay.
And based on this df, we need to find out the tree clustering. So how can we do it in unsupervised learning? The target is there, just for namesake I put it to show you something. In clustering is not required. df target is equal to what? df for target is what? Target is a name, right? Any name you can give. So any name you can put it. Instead of that, what I put it? df target. So the target will be here. Column name I give, and that is dictionary iris target column name. So the data from that sklearn iris sklearn data sets will, the target, whatever is present in the key target will be come to this one, right?
The name can be anything.
Yeah, you can give any name, you can change it, right? So now it change to class.
Okay, sir.
So what? So see what is so here why we put people and people and petal width, and after that here df class. There is target predict class. Now it's I have to rerun it. So because of that, something here. See, this one is something was wrong in the notepad. Sometimes it gives you fake you. Now see. So this is where you understand, right? So but we don't require the target. So what is the main thing is there? From sklearn cluster import k-means. So this is their scikit-learn algorithm. In the cluster, it is k-means, import k-means. This is a k-means clustering is there.
Okay, sir.
So k-means you have to put the number of clusters. So how many clusters are there in iris?
3.
Features name it is given already 3. So we put 3 and maximum iterations we put, so that algorithm will stop in that. After that it will not work. So the 3 cluster centers will be optimized and it will stop. More than
Sir,
1
1 minute. Yes, sir. Sir, if the number of features are 5, then the maximum clusters are equal to 5, no, sir?
Yes, yes, yes. Number of samples we want, that is number of clusters. See, let's say we don't know the target, but we know what is there, right? So if I say divide the population of Bangalore into 3 groups,
Mm.
maybe I'm not saying that divide it into income of less than 30,000, 30,000 to 1 lakhs or above 1 lakhs. I am not saying like that.
Mm.
I say divide it into 3 groups, right?
Mm. Mm. Mm.
So that is the difference of.
Okay, sir.
So now running this, so the KM object is returned. Dot feed, you have to supply only features.
Mm.
Okay, only features. Features is what? This X, right?
Mm. Yes, sir.
So that dot feed X. So it will run the algorithm auto. Iteration is 1000. Number of cluster is 3. Parallel job is 1 because one CPU I think is used. So after that, this is done. Your clustering is done. Then how can you see the centers? Cluster center underscore centers underscore is. This is the variable which will give you km dot. You have to put it. Km is that object, right? So this will be giving you the 3 centers. Now tell
Okay,
me
sir.
what does the centers look like? 4 columns, right?
Mm.
And 3 rows. 3 rows indicate 3 centers.
Mm.
And 4 columns, why? Because you have 4 features.
Okay, sir. Sir,
So
but what does this fittex will do? So they basically you're taking them from data sets KM, no, sir?
which one?
23, sir.
Which one?
23, 23, 23. IN
23.
23.
24.
Sorry, sir. Sorry. Yes, sir. And there is a yes, sir. There is a fittex, and again from the X is the data set. No, sir. X is the data set we are going to take the input data set. And what is the fittex will do? So fittex will do all these
1 minute,
operations.
1 minute, wait. 1 minute, phone is there. Hello? They say, call them. They said accounting will call you. They are going to deposit. Till now, the transfer is not happening. But they said that after lunch also I called that when is going to deposit. So I'm here only. I'll call you. Might be. Yeah, yeah, you should deposit. Because yesterday only confirmed they otherwise the two guys I confirmed, one lady or one guy. Yes. Tell me, Nipsey. So
Yeah.
this one,
So
feed X.
basically, sir, fittex X is the data set. No, sir. X is the data set we're going to take.
Yes, yes, data set.
And the
Features
KM
out of there, not the target, features only.
and feature and the KM is it finds the mean value of the cluster of the three features, and maximum iteration is equal to 1000. That will be stored in the KM.
Maximum iteration, yes, yes. See, K means we specify in there, yeah, number of clusters should be 3, and the iteration is there. From there, that algorithm we run and create the objects for there. So,
Okay.
so you understand that using the principle in this data set is going to run the algorithm to find 3 clusters with maximum iteration of this much.
Hmm.
And this
Okay.
produces you the cluster centers and all. So the
So
cluster centers.
what does this fittex will do? So what is the function of this fittex? It will
Fittex
basically
is
find out
always
the
used to feed the data using the algorithm.
data, fill the data.
Feed the data in the XYZ plane, whatever it is. So it is the statistical graph it will find out, or the circle or whatever is according to the formula. It will feed the data
Mm-hmm.
using the algorithm.
Mm-hmm. Okay, fittex. Okay. Okay.
So Cluster centers is the 3 clusters with 4 columns.
Three,
Four,
basically 4 columns indicates the 4 features, and 3 indicates the three
three
centers.
centers.
Okay.
So down I have drawn a picture also for that.
1 minute. So 3 centers means 5.901
That I will
5.9.
explain you. That I will explain you down. I will explain you. Here is a diagram is there. Wait, I will explain you that.
Okay.
So yeah. So KM labels is what? KM labels is the what it find out. So it find out one type of flowers. That is, its label is a one. One does not indicate it's a Sartosa or versicolor or veronica or something.
Uh,
One indicates it's a one type
mm,
because it has
okay.
mentioned a type. So it is a mention because in the numbers it mentioned that it's a one type only.
Mm,
Similarly, 0 is one type and 2 is one type. But
okay.
then, yeah, but then if you see there are 0 in between 2, this is outlier. This is 2, this is a misclassification.
Yes, sir.
So these are misclassification.
Miss.
Yeah, misclustering it. It's a different types actually. So
Mm-hmm.
2 type is coming in between that, right?
Yes, sir.
So
Should we take out the type of clustering, sir? We should take out the basic clustering.
yes. So we'll take a class on the outlier. Outlier in the video also I have said something about outlier. So in a clustering, how can we do outliers? We'll do that.
Mm,
So misclustering can happen after outliers also.
mm-hmm.
So see, this is because algorithm cannot be 100% perfect.
Nowhere it is, sir. Yes, sir.
So DFKM labels is what we put in the predict columns one, and just to put a comparison study, we put it here. So how it is formed.
Mm,
So see, this is the actual data is mentioned as one type, and
mm,
we have found it's a one type. Rather than 0 and 1 is different, we don't say that it's a miss because the clustering problem. We have not trained that if this is the data set, it is 0,
yes, sir.
and this is there with 0. We have not given the target. So it's saying that it's
Mm,
a one type. It's also saying a one type. That is okay. Unless in between a 1 there is 2 or 0, it's all okay.
mm,
When it comes to 2, it should be all 2. In between that 0 is there means it's a wrong classification.
okay.
Wrong clustering.
Sir, but in the previous one, there is 0 and 1, no, sir? That's a wrong classification, sir.
Which one?
0 and 1. Class is 0, predict is 1. 28, sir. 28.
No. That's what I'm saying. So when you do the clustering, we have not trained according to that target. This target is not mentioned, right?
Oh,
This target we have just for the data we have, and I show you. See, we have trained it only X. It doesn't know what is Y. It
mm,
doesn't know what is target.
mm,
It says only that first bunch of flower is of one type. It separate out one type in a one space. Right? If you
okay.
have blue rose, red rose and white rose mix up, it just will keep it in one place. It doesn't know it's called a white rose. Machine will not
Sir,
know the one time the name is white rose because you have not trained it. It will only
yes,
pick
sir.
a bunch and say that it's a one type.
Yes, sir. We did not train anything, but the class which is specified is 0. Yes, sir. Class which
The
is
class
specified is 0.
there is no count. This is just to show the class is nowhere. Did we use somewhere? No, right?
Mm.
Y variable is not there, right? Only XV2 data.
Yes,
Data
sir.
is this one. We didn't use
Mm.
that class variable.
Oh, yes, sir.
No, we didn't use. Otherwise, we have used this like this x comma y, right?
Yes, sir.
So
Sir,
the
but what does this X indicate? What does this class indicate, sir? This class.
class is that this one. See, what is the class indicates here? 1 minute. Hello. Class doctor ঠিক আছে মাই লই যায় সিগর কোন কথা নাই yeah see this is the class, right? Hello.
Yes, sir.
The class is what? The target.
Yes, sir. Class target. Yes, sir.
Target. So target is already, this is given, but I'm saying that for the data set we are using without target. I'm just printing it. If you don't want to, if you're getting confused, I'll remove it. Just, this is not required for clustering analysis. Clustering analysis, this is at all not required. See, we are not interested in this one, right? So we put it like this. So DF having 4 features. And we have targeted as one time. So as per features. So right now, any confusion?
So we are going to predict. Okay, the prediction is 111. Okay.
Prediction means nothing. I just put a name predict. So it is not predicting.
Yes,
It's
sir.
just clustering.
That's what, sir. The predict when.
So clusters as one type, other type, or other type. Right? So labels indicate it's a one type. This is
Yes,
other type, and this is other type. That is what we printed here in the column to show in parallel. You don't need to mention this in the. You don't need to mention this step actually. If you see, you don't require this one actually. Okay. You don't require these steps.
Okay.
And why there are 4 columns in there? Because 3 centroids are there, right? 3 centroids we found that has a position what? In this is the x and y plane, correct?
Yes, sir.
So in x and y plane, we can take 2 features only to represent it. So if you have 3 features, then how it will represent? The distance in the x direction, y direction, and z direction. See, it is like this. So I had a new slide, so I will tell you sometimes. 1 minute, give me 1 minute. Hello? Hello?
Yes, sir.
Minipsi 1 minute. Kona, my here se dola person. Okay, see, this one.
Sir, we don't have a gradient descent, no, sir?
No, I will tell you. This one slide was not there that time. I told you, but this much of information was not there. Not this one. Actually, I have to tell you this. So you are seeing that there are many. Now we have 4 features, right, in this analysis. How many features you have now in this? 4, right?
But we actually have 3 only, no, sir. But actually we have only 3.
Huh? No. 3 type of flowers are there. Now features means what?
Height, width.
No, that is I'm not saying. See, when there are two plants, only 2 variable x and y. Y dependent on x. When there is only one variable, that is x, and this is the target. That is means here I am saying only one. Let's say only simple length is there.
Only simple?
Only simple length. One column is there. Column means features. You forgot that.
Yes.
Class means the target. The target. This is features means always the apart from target, the data whatever is there in column. This is called features.
Yes, sir.
So if you have one features only x, and what is the regression problem? It will change like if it is x, what is the value of this one? If it is x, what is the value change in y? Means if there is change in x at this much, what is the change in y?
Yes,
So
sir.
there is a regression problem. So a point, what I'm saying, a target. Let's say we have 2 features, and we have to put a cluster. So this is x direction, this is y direction. So how will calculate? If I say simple length is this much and simple width is this much, how will go? You will come this way, then this way, right? If there is a 3 axis is there like this, what will do? Simple length is, let's say I say this much, simple width is y direction this much. So it will go like this and like this, right?
Yes, sir.
So marker is not below because this is PDF. Sorry. So it will go like this and like this, right? Can I put a marker? No. The PDF I can have. Here I cannot. That will be the PDF. So I'm saying there are 3 axes is there. Then simple length is like this. Simple width is like this. And again, let's say in petal length is z direction. So it will be in this direction, right?
Yes, sir.
So ultimately, your point will be in this way, right? There. You have to consider z also, x also, y also. And if there is one more dimension, you have to consider that also, right? To plot a point. If I say a point, this point has to be calculated based from the distance of x, distance of y, and distance of z. How will go? X is this much, y this much, right?
Yes, sir.
And in z direction this much. So we have to go in z direction also, right? It will come out of this in this way.
Yes, sir.
Right? So if there are 4 axes, then the coordinates will be based on the 4. And now I'll tell you what I wanted to indicate you. Now you have 4 features: simple length, simple width, petal width. So if you have to draw, we cannot draw 4 dimension. Let's say 3 dimension. So if I put a 3 dimension and if I put a cluster centers, this one. So I have to put a 3 axis and I have to find a cluster centers. So as a 3 dimension also difficult, so we put 2 dimension only. And this one I actually wanted to explain you these things. Cluster centers. So as we have 4 axes, 4 features, so it takes a x, sepal length, sepal width, petal length, petal width.
Okay, sir.
And positioning it in x, y, z and other one plan, it will get the coordinates.
Okay, sir.
Right? If it is missing the last one, and if I put 3, that means what? X direction, y direction, z direction. X, y, z, correct?
Yes, sir.
So in that basic basis, we got a 3 centers. Now, do you understand why we have 4 different numbers in every centers?
Yes, sir. Because we have 4 features.
4 features. If you have 5, then 5 dimension. I always tell that the features are number of features are interpreted as 1 dimension in machine learning.
Okay. Okay, that means that's why we have 4 features. We have 3 coordinates, so that's why we got 3 columns there.
No, 3 columns, 3 rows. That indicates one center.
Sorry. 3 rows. Sorry. 3 rows we have, but we have 4 features, so that's why we got 4 center values for 4 features in 3 columns, 3 dimensions.
Yes. So now to represent that, we see put a clusters matplotlib, the scatter plot we put, and as we cannot plot, 4 variables, we put only 2. X is what? X is the data only.
Yes, sir.
This X is the data only.
Yes, sir.
In that X, I put all rows starting with 0 column, all rows starting with first column. And C is equal to Y means what? Y means these are predicted value.
Which one, sir? Yes, sir.
Here, so y means in one variable we took the km predict x. Km predict x means ultimately these are the same thing only. Y underscore MEANS. Y k means. See, these are same thing, right? Km labels only, right?
Okay.
Y means km dot predict based on x means what is the cluster we have identified. Again, the features row number 1, row number 2. You can do it like this also, and km dot labels also is same. Okay. Understood?
Okay, sir.
So,
Sir, but how we are getting the target variable, sir? How we are getting the target variable is that's my the prediction which I are going to write is the target variable.
Predicting is not giving you a target and cannot match with the old target because we have not trained with the target, right? It is giving you a type, one type.
Okay. Only the type of the
Yeah, machine cannot say yellow or blue or something, right? We have not trained the visualization and said it is a yellow color. Did we say it? No, right? We did you say that Sartosa is a light green or something? No, right? And his name is yellow. We didn't say. How we can understand? It's only
Okay,
group.
but
Put a name, number on it, 0 or 1 or 2.
that means we'll give the feature. Out of that features, it will say what type. It may be yellow type or blue type or red type. That's it.
Whatever may be, just keep some 10, 12 stones, different colors, and put the algorithm. The algorithm should be able to put the same colors in a different space, but he don't know it's called a yellow or because something blue, right?
Okay, from the features, it is telling just from the feature, just is giving the 0, 1, 2. It's a type. That's it.
Similar data in one space.
Okay,
Because
similar.
similar
Just
data, how we
classifying
can
the.
find out? Because sepal and
Okay,
sepal width are different, right? Petal and petal width are different. Based on the measurement, we find out similar data in one space.
okay. Only it is doing the classification similar data types in one type and another similar data type without giving any training.
Without giving with the training with the target.
Okay, without giving any target, it's just able to classify. That's it.
Yeah, clustering, not classified.
Yeah, clustering means all similar data types in one type.
Clustering means grouping, group.
That's also all group in one, another
Yeah.
group in another,
Just
all.
like if the
That means
height of 4 feet, 5 feet, and 6 feet people are standing, the algorithm can separate out 4 feet, 5 feet, and 6 feet based on his height, based on his weight, based on his shoulder length, and all. But it cannot say it's a 6 feet, it's a 4 feet, or it's a 5 feet.
okay, it can classify either it is a medium or
It
short
will
or
not
tall.
say
That's
it's
it.
a tall people, this is a medium tall, and this is short people. It will say it's a one type 0, 1, 2.
Okay, it can only classify that it's a medium people. These are large people. These are short people. That's it. But
Yes.
but what is the size of the medium? It can't say. Okay,
No. Then
okay, that's a drawback of this algorithm. Okay.
here at a representation is what? The target variables. Target variables means that grouping now already done.
Hmm.
Right? Y means is a target that is already grouping is done. So C is equal to Y means you put and S is equal to 50 means the size of the sample. When you put 200, it will give you big. So S is that and C map is equal to this we put, so it will put different colors.
Hmm.
It has many colors inside it, so it will take some random colors out of it, and it will represent that data in X. Only we took 2 columns, see, because we cannot take 4 columns. 4 features we do, 2 features we do, only sepal length and sepal width.
Hmm.
And in sepal length, sepal width we took in X and Y,
Hmm.
and X and Y, and what we did, and data is, so data is what we do, the clustering, right? Clustering data.
Okay, sir.
So
Okay, sir.
this
That
way,
means it will clustering means basically all the similar all will in a group, all the similar group will be in one type, and all the similar another similar group in one type, another similar group in another type. That's it.
yes, yes.
Okay, and it gives what VR at DS is the different colors we are going to give.
Pardon?
C map is equal to VIR DIS. It basically gives a color.
Yeah.
Mm-hmm.
So
Okay, sir.
see, I have removed this one. C is equal to this one. So I have removed this. So see, C has a type, right? Color, black. I put it black, so it put it black.
Hmm.
And here it is, we put Y means, Y underscore means has what? 0, 1, and 2, right?
Yes, sir.
0, 1, and 2 array. So whenever you get a 1, it's put a different colors and so on.
Hmm.
See, now color has been changed.
ಇಲ್ಲ ಚಾರ್ಜಿಂಗ್ ಹೋಗ್ತದೆ ಕ್ಲಾಸ್ ಹೋದ್ರೆ
Three colors it put based on the data type. And the centers, what is the centers? Right? Cluster centers is what? KM cluster centers is this one, right? So centers we put centers is equal to KM cluster centers. So these
Okay.
4 out of that, as you know already, cluster centers has what 4 columns, but we took only 2 columns, first and second, 0 and first, 0 and first column, right? That is
Okay, sir.
centers 0 and centers 1 column. And we want the black color, so that 3 black spot you can see.
Okay.
And the size we have made bigger to make it prompt.
Okay. So the center which you're taken only for first 2, that's it. You can, sir, you can take it for complete, like you can take it for 3?
Yes, you can take it for 3. So another, I think, steps you need to be do some loops and one for 3D visualization.
Centers.
No, it doesn't work. Oh, sorry. So got multiple argument for S. Yeah. So 3-dimensional plot is little different. Let's see here. This way you have to do. Okay, so this is right. So we can take it from here. So you have to put 3D plot. So these things. So data is not there. Okay, wait.
Sir, we have 3 properties, thus we get 3-dimensional, sir.
Yes, yes.
If we have 4 features, we have 4-dimensional.
Yeah, 4 dimension. So,
Sir, but practically, if we have suppose 26 features or 28 features, then we can't
yeah.
have 25 dimensions.
So cannot display. That is, yeah, up to 3 dimension you can display it, but the machine behaves. That's why so when you say gradient, so if there is one features, so if your that's why if your experience is, um, let's say 2 years experience candidate is getting 30,000 salary.
Sir?
So 4 years is getting 50,000. So what you'll say, when the value of x is 3 years or 2 years, so value of x is 2, then changes. What is the dy by dx?
Sir?
See, I will show you that one on neural network machine. What is gone? Where is that document? Machine regression on this. See how it calculates internally is it takes every, like if you see continuous data, no? What is the value of change in x? What is the value of y when there is a change in x? That is called slope, dy by dx.
Okay, sir.
So if we say that, I say that number of years of experience 5 and salary is 5 lakhs, number of experience is 10 years and 10 lakhs. So that means when the sale value is changing 5 in x direction, y changes to how much? 5.
5.
So dy by dx 5 by 5.
1.
Yeah. So and then so accordingly, when the value of change is x, what is the change in y compared to x? So that is how slope is formed. But when there is another dimension z, so then it is counted as like this. It will happen like this. That is because dy by dx plus dz by dy by dz. See, the equation is like this, right? m1x dy by dx into x plus m2 means change in y with respect to z into z plus c. This is the equation.
Yes, sir.
So it calculates. You cannot display everything, but it's an example of linear regression or regression problem. So everywhere, if there is one more axis m, then the value of change in y with respect to m. What is y now? Target. That means if it is a regression problem, how can you say that that when there is a change in triple and this, what is the value change in clustering target? Let's say it is a price or something. It's the value of this, how it is the changes. Again, this column will work in machine learning. When this is this much changes, what is the changes in this? This is this. Again, this will do compare with the class, right? So all the axes, all the features you will take in another axis, and it will see that dy by dx, dy by dx2, let's say, dy by dx3, dy by dx4, like that for every row it will take, and then take a the equation is y equal to m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 That is y value. Again, let's say price is 20 lakhs, in 30 lakhs. 30 is equal to what? This is right x. This into dy by dx. This into dy by dx2. Let's say this into dy by dx3. Like that. So there is a every dimension it works out. So this is why. So we'll speak on more on the regression on that. 2 slides I have to take it out. So I have to talk on that slides. I don't know who sent who is that. So yeah. So now. So then you have to put this one, right? Y is equal to okay. So this figure is in 3 dimensions. Something is wrong. So I will check it out. Huh? At the moment I don't like to say what is wrong might be. You can also check it out. Okay, you can work on this diagram. Hello.
Yes, sir. That is.
Yeah, just check on that what is wrong. C is equal to y. I think it's wrong. Y is not there, right? So we can replace what is required here. C is equal to y means. Now you can see, right?
Yes, sir. All 3 dimensions it is taking.
So similarly, you can plot the centers also. You will try how to plot the centers same way. Okay. So today we'll stop here.
Oh, okay, sir. Fine, sir.
Okay. So tomorrow will be here.
Oh, okay, sir. Fine, sir. Thanks.
Yeah, tomorrow you can be there, right?
Tomorrow I'll come.